iterations instead of 4096. So this is just running on my PC, and it's a little bit faster, as you can see. It should find it pretty soon. There we go. So I found the passphrase, which is 1, 2, 3, 4, 5, 6. And so then you just feed it with the same arguments, but you also give it the FPGA number, which is 0 because I only have 1 in here. And this should run it on the FPGA. So right now it's doing about 2,000 per second, and it found it in a couple seconds there. All right, well, if you want to see how that whole thing works, check out their talk tomorrow. And some conclusions here: get an FPGA and start cracking. You know, download some of my code, try running it, make your own code, whatever. Add cool matrix ASCII effects when you can, because you aren't trying to, you know, just like squeeze that extra, you know, like assembly code out of your optimizations. And I don't know, you can waste tons of CPU cycles doing cool stuff instead of cracking passwords now. And choose bad passwords, please. That's always a good thing to do. So that's our card. It actually, the reason why it's so expensive is it has a bunch of other stuff on it. If you want to look at this later, come up here and I'll show you. But it has tons of other stuff on it. It's got 64 megs of flash, 128 megs of RAM, gigabit Ethernet. You can get it with a PowerPC on it if you want. And you can run Linux on it and stuff like that. We sell them in clusters of 15, so if you take the $2,500 and multiply it by 15, that's about how much this thing costs, which is pretty pricey. We're also working on Express Card that'll run in your MacBook Pro. And I've got PCBs here. We're still working on getting all the software working on it right now, but this is kind of like our crypto cracking card of the future, which will probably be out in a few months. And it has a lot less stuff on it, so it's easier for us to manufacture. We're going to price it maybe around $1,000 or so. And it should be about 3 times faster than our compact flash one, because it uses the newer chips and stuff. But expect to see this come out in a few months if you're interested in buying some stuff. And some thanks, Johnny Cash for doing Airbase, Josh Wright for writing CowPatty, RenderMan for getting me to generate some hash tables, Beetle, who found out how to do this on OS X pretty easily, and Jake Applebaum and Ralph Weinman, and the audience here. You're pretty cool. So here's all my info. If you have any questions, feel free to ask them. Any questions? Yeah, back there.
Have you, sorry, I just said, okay. All right. Have you considered applying this FPGA cracking to any other crypto algorithms than the WPA and the Landman hashes and the demos you showed? I'm sorry if you covered that already. I missed the beginning of your talk.
Yeah, actually, that's a good question for people here. The tough thing is that a lot of stuff out there is kind of made so even if you can crack it like 1,000 times faster, you still can't really crack it. Like 128-bit or even 256-bit is still pretty impossible. So there's a lot of stuff out there that's kind of too tough, and so I'm just kind of looking for the low-hanging fruit of crypto stuff. And even when you think about it, like FileVault and CowPatty, it only does like maybe a few hundred or a few thousand per second, and so that's like way too slow to even think of doing a brute force attack on it. So it's mostly just kind of trying different passwords and seeing if they work. If you guys have any ideas on like the kind of the low-hanging fruit, where if I could do this 100 times faster or 1,000 times faster, then I could totally break this. Please let me know, because I'm trying to find those. One thing that I have been thinking about is it turns out that WinZip also uses the PBKDF2 stuff. So and I think it actually uses 1,000 iterations. So probably this stuff could be easily used on WinZip also. That's a question for you guys. Do you have any ideas of things that I could use this for? Or anybody? Or do you know of anything?
No, sorry. I just have a friend of mine who does some research on RSA.
Oh, okay.
Well, yeah.
Oh, yeah. I kind of mentioned I'd talk about some RSA stuff, but
okay.
Yeah, I don't really have anything prepared. I kind of threw in this other stuff instead. So
yeah. Thanks anyway.
Yeah, thanks. Any other questions or comments? Anything that should be cracked? Yeah.
What's the I/O bandwidth between the FPGA and your computer?
What's that?
The I/O bandwidth between FPGA and your computer.
The I/O bandwidth. Compact Flash is extremely slow. This card maybe tops out at a couple megabytes per second, just because of the bus. So it's only really useful for applications where you're just sending a little bit of data and then it's doing tons of computation on the card and just spits back a little bit of data. Yeah, so with our card bus card that we also sell, that'll top out at about a theoretical gigabit per second, but in reality it's maybe about half that. With our Express card, that'll top out at about 2.5 gigabits per second full duplex, and so maybe you're going to get half that or a little over half that, but the Express card is definitely a better solution for applications where you're sending lots of data back across the bus.
Yeah, that sounds pretty fast. A couple of years ago, there was a talk here about a possible kernel accelerator device. Have you heard of it? They tried to implement crypto and so on FPGAs and provide these services via Linux kernel modules. So what I would be interested in is how many times can you reprogram these FPGAs, since it might be necessary to reconfigure them once in a second or maybe once a minute or something.
Yeah. That's kind of interesting that you brought that up, because our Compact Flash one, actually it has a flash ROM on there that we use to load the FPGA from. And so you have to upload your image to the flash and then tell it, okay, load this particular image off the flash onto the FPGA. And so that takes some time just because the flash is really slow and you have to program it first. With our Express card, we actually designed it so it has an external Express card PHY on it. So when you plug it in, it recognizes it and stuff like that, but it doesn't actually have anything on the FPGA. And you can use the extra chip on there to program it directly from your PC. So you don't have to upload anything first. You just stream the file directly onto it. And so it's a lot faster. You can program it like almost instantaneously. I think that with this one, it's like a few milliseconds to program, and with this it would be like in the microsecond sort of range. So so we're really designing this so you have to plug it into a PC. You can't run it standalone like this one, and make it so it's really quick to swap out images, rebuild them, and change them out whenever you want. And you could also do like partial reconfiguration if you just want to change one particular algorithm on there, or change resources and stuff. So this one's kind of like our future sort of idea for crypto cracking stuff. Any other questions? Oh, go ahead.
Just a second.
Oh.
I was just wondering, do you need export licenses for these devices in the US these days, or?
I don't think so. The FPGAs themselves are mostly manufactured in like other countries, and the actual code is all open source, so it kind of falls under the open source export licenses, I guess.
Yeah, right, but no, I'm asking about the hardware.
The hardware? I don't think so. I think we're still working on trying to get a distributor in Europe, but I mean, if you want to buy one, we can just mail it to you or something. I don't know. I guess we haven't had anybody come up to us about that. So. Oh, back there? Me? Oh, sorry.
Well,
I guess, yeah, why don't you go ahead first then?
Your competition has implementations of FPGAs hooked up to hypertransport systems. Do you have anything planned in that regard? You have a dual socket Opteron. You have an Opteron plugged into one socket and the other one is the FPGA, so you have a very high bandwidth.
Yeah, like the DRC chips. Yeah, there's this company called DRC that makes an FPGA that plugs into an Opteron socket. And so if you have, so it basically uses hypertransport for the bus, and it's a lot faster. We don't have anything that does that. We were just kind of, our whole idea on that is that, like with the limitations on how fast like RAM can transfer and stuff like that, it just seemed like it would be a better option to go to PCI Express, because we're building backplanes so you can plug like 8 of these into a backplane and use 8x PCI Express, and that seems like it'd be fast enough for our purposes. But yeah, for I guess extremely high speed stuff, it seems like you get to a certain point where you can't transfer it off of your, like 1,000 hard drive RAID array fast enough, or transfer it onto it. And I don't know, it seems like there's kind of a top of the line where, you can't, where your bus doesn't really matter in certain applications. So do you have any applications where you could use, like tens of gigabits per second?
Well, we're actually looking into structured Gauss over finite fields.
Oh, okay.
Basically doing a couple ideas. There's nothing concrete yet, but attacking AES or at least the toy examples initially, and then
okay.
seeing how far we get. And it's there's several attempts either over F5, so it's a border it's a Gertner-based computation, or alternatively trying to do it with border bases, but. And then just, I mean, any kind of linear system solving over finite fields.
Oh, okay. But so you require a lot of data for that, or?
Yeah, I mean, having 10 or 20 gigs of total data at the very end is not that unusual. I mean, certainly 32 or 256 megabytes is not going to cut it.
Yeah. Oh, yeah. So you're talking about like for your tables and stuff like that, you need to be able to save it off and pull it in and stuff.
Well, the systems have a tendency to get quite large. They are usually over F2 or F2P. So, I mean, it's all at an experimental stage. We're doing work for an unnamed ugly big oil company, and we have some resource money to buy funny stuff and try to explain to them why we need that for their particular research purpose. But we are doing crypto research on the side. And
I guess if you're trying to, if it's really important that they need to communicate with each other fast, then you might want to go with the DRC or I guess like Cray has their own FPGA stuff in the XD1 that uses a higher speed backplane or something. But yeah, we're kind of aiming more towards something that you can plug into your laptop, and then if you want to, do all your development on your laptop and then take them out, plug them into your server, and have a bunch of them there, and just make it really scalable like that instead of the really high-end sort of academic stuff. Any other questions?
It's just for an information. We have ordered some FPGA 4 from Virtex, and we need an agreement, an export agreement, because the US government don't want some people use this FPGA for make nuclear bomb or massive destruction weapon. So we need an agreement.
Oh, interesting. What is the law like for that? Or can you explain that more?
Excuse me, I don't understand exactly.
Oh, I guess we can. I'd be interested in what the laws are like for that. Maybe we can talk about it later, offsite.
Yeah.
Okay. Yeah, go ahead.
Did you know any open source software for using and emulating HDL code before sending into FPGA or CPLD, or did we have to use proprietary software before using any FPGA?
That's a good question. There's an open source simulator called Icarus that you can use for, you just write your Verilog and then you can simulate it, and it'll run as if it was on an FPGA. But Xilinx is the only company that has something that'll actually, build the files that you can load on the FPGA, since it's all proprietary. But I know a lot of people that do all their stuff in Icarus, and then when they actually go to use it on the FPGA, then they run it through the tools. And all their tools are pretty much free. You can download trial versions from their website. They have a Linux version that only runs on Red Hat Enterprise, but it's based on command line tools. So you can script it all to build your stuff, and so it's not too bad. Go ahead.
Do you have any experience with some advanced synthesis tool like Synopsys? Not Synopsys, Simplify?
Oh, Simplify?
Yeah,
a little bit.
Instead of the ISC?
Yeah, I've used it a little bit, but I kind of prefer to use ISC stuff just because people that are downloading this off the website and building it don't really want to spend $20,000 on Simplify to build it. And so if I make all my code so it only runs on Simplify, then it kind of reduces our amount of people that can use our stuff. But we have used it for some of our kind of higher end designs that are proprietary. But I kind of prefer the Xilinx stuff personally. So any other questions? All right. If you have any other questions, feel free to come up and ask me. I'll have these cards laying up here, but thanks a lot for your time.